This video is on Boyles' law, discovered by Robert Boyle in 1662. And so this has to deal with the relationship between pressure and volume. Those are my symbols for pressure and volume, commonly used throughout the chemistry and physics world. What we're going to do is a thought experiment. We're going to take a gas, and we're going to put it in, and we're going to put a pin here. And so this gas has a measurable volume. It's the volume of the container, and it has a pressure. We don't know what it is, but we'll call it our initial pressure, P initial, and our initial volume, V initial. And so what we do is we take and we push on this, and we're going to push down hard, and we're going to apply pressure to the outside. And so what do we expect to have happen to the volume and the pressure? So if your own experience should inform you that if we push hard on this, the volume is going to decrease because this piston is going to move down. And so we have a smaller volume. We'll put a little pin in here to hold it so it can't expand. And what happens to the pressure? Well, your thought idea should be the pressure increases. So we're pushing down on the outside of this. Now we're done pushing, but we've reached this. What we see overall is as we increase the pressure, the volume decreases. So this is called inversely proportional. It's equal to 1 over V times some constant C. If I take the volume, if I multiply both sides by volume, I get PV equal a constant. And I'm going to call this P initial, V initial, P initial, V initial. So on my left side I have P initial times V initial equal constant. And then when I come over here, my pressure increased, the volume decreased. Okay, so if pressure goes up, volume goes down. That makes this side bigger when the volume goes down. And so I have it all equal to the same constant. So P final on this side times V final is equal to a constant. It's the same constant. And thus we come up with Boyle's law from these two being both equal to the same constant. We can set them equal, and we have P initial times V initial equal P final times V final. And it doesn't, people really don't normally say that. They normally go P1 V1 equal P2 V2. Now, in this problem, the units don't matter as long as they're consistent. So if I have the pressure in torr, P1, P2 has to also be torr. If I have then V1 is in liters, V2 must be in liters. That's all it really matters. So whatever units I use, I could use gallons for the volume, then the unit over here would be gallon. Whatever units you use to start with is what you end up with in the end. And so we have a bunch of problems that I'm going to set up a couple of them and show you. So here's an example problem. I got 2.5 liters of gas, helium gas, at 850 torr, and it's expanded to 732 torr. And I want to know what the final volume is. So how to do this, I write down what I know. P1, 850 torr, and V1 is 2.5 liters. These are what the gas is initially at. You could call it P initial and V initial. P final equals 732 torr, and I want to know what V final is. And so all I do is I write my equation down, P1 V1 equal P2 V2, or P initial V initial equal P final V final. Okay, and I divide both sides by P2. That will cancel over here, and I get V2 is equal to P1 V1 over P2, and all I do is I plug my numbers in. And so I got 850 torr times V2 is 2.5 liters divided by 732. That answer is 2.90 liters. I'm not real concerned about sig figs on these. All right, I'll do one more a little bit harder. Okay, here's my next problem. I have 3 gallons of oxygen gas at 5.67 atmosphere, and it's expanded to 6 gallons. What is the final pressure in torr of the oxygen? So once again, I say that V1 equal 3.00 gallon, P1 equal 5.67 atmosphere, and V2, the final volume, is 6.00 gallon, and we want to know what the final pressure is. Okay, so piece of cake, P1 V1 equal P2 V2. I want to solve for P2. So I divide both sides by V2, and I cancel on this side, and I get P2 equal P1 V1 for V2. So I just plug these in. P2 equal, P1 is 5.67 atmospheres times V2, which is 6.00 gallons, divided by 3.00 gallons, and I solve for that with my, when I solve for this with my calculator, I get 11.34 atmospheres. Uh-oh, I got a big mistake. I got my P1s and V1s mixed up. So, got to be real careful here. I misread this, and I wasn't careful. So that's a good example of what not to do. I'm going to re-plug these in. So I re-plugged in, and I got my volume correct this time, V1 and V2. That's a good example of be careful with these. Plug it in the right places. And I now get P2 equal 2.88 atmosphere. Unfortunately, I asked for it in torr, so I'll do a conversion. 2.88 atmosphere times 760 torr per 1 atmosphere, and I get 2,189 torr. And again, I'm not real careful about sig figs on these. Just using up. There you go.